Good morning. Here we want to study about the frame synchronization. In previous session we have seen about the bit synchronization. At that time what we are saying, if we are supposed to use bit synchronization, at that time we are having the three different methods in which we are detecting the binary signal at the receiver, which we are supposed to sample at the precise instant. It means what? Here we will require the clock signal at the receiver side that will be in synchronization with the receiver. So here we are saying the method of extracting a bit, we are saying that as a bit synchronization. So here we are doing the three methods. We can extract the clock signal from the signal. We can say self-synchronization. Transmitting the clock from transmitter to receiver, or derivation of a clock signal from the master timing source. Both we can do at the transmitter and the receiver. Now we can see here about the frame synchronization. So here when we are using the bit synchronization, at that time we are saying if we are sending a data that will be sending, which will allows the receiver to initialize the synchronize its clock with the one of its sender. So here we will require the synchronization, but as initial synchronization we are losing because we are sending here a bit stream, means we are sending the frame. So we can say because this initial synchronization might get lost as frame is transmitted in the digital phase lock loop that can be used to keep the receiver and transmitter synchronized. So we can use the DPLL. So when we are talking about the frame synchronization, at that time here receiver should know when transmission will begin and when it will end. So otherwise if he will not know when transmitter is sending and when it will end the transmission, so there will be no transmission because noise signal will get produced, it will produces random bits. So in case of TDM, time division multiplexing, message from various sources from apart from frame that will get at the receiver. Such entire message has many subdivisions in the TDM. So these subdivisions to be identified at the receiver in order to distribute them at a proper destination. So at the beginning of each transmission or each frame, a particular bit pattern is used which can be identified at the receiver at a start of transmission. We can say that as a frame synchronization. It means what? At the beginning of the transmission, several repetition of the synchronization words are transmitted to acquire the bit synchronization. So here when we are sending the data, the start of message that we are transmitting, which will tells the receiver that message is following, and when transmission is over, the end of message is sent to inform the receiver that there is no more data available for the transmission. So here we will not lose any information and we will send the correct information because we are sending at the start. So in case of identification of a frame, a synchronization word is attached at the beginning of each frame. We can say that as a preambler. You can observe here the waveform. Here we are saying when we are supposed to use the frame synchronization, at that time if we will use the mixture of the time gap and the length indication for the frame synchronization. At that time it will shows the structure of frame. So each frame will start with already mentioned, which we are giving. We are saying that as a already mentioned preamble, which is followed by the start of frame delimiter. We can say start of frame delimiter as a SFD, which its binary value is 10101011, and it is followed by the destination address, and it will be followed by the source address, both of which are the 6 byte. I have given here its length also. So we can see the waveform, you can see the diagram. So it will be allowed, both are having the 6 byte. After that it will be followed by the length indicator, which will be of 2 bytes, which will indicating how many bytes will be within the following data field. This diagram you will require because it is a typical frame structure. And after that, when we are giving the length bit at that time, after this actual frame data is sent, which may not be longer than the 1500 bytes. And finally a 4 byte frame that we are using as a CRC. It is nothing but cycling redundancy check that can be sent. So here we can see the diagram, that is the typical frame for the data structure. At the beginning of the transmission we are sending here to get the bit synchronization. So we can say when we are sending the data, at that time receiver should know where transmission will begin and where it will be ended. So here if we are not doing the transmission accurately, there will get the production of the noise. So here when at the beginning of each transmission, if frame is used which can be identified at the receiver end and at the start of transmission or at the start of frame, we can say that as a frame synchronization. So here after the sender start with the preamble, all receiver will synchronize to its clock. So here when they will scanning the data for SFD signal, at the receiver encounter the signal, it will start the recording the data sent on the medium, and after it has received the next 14 bytes. These are nothing but SFD, destination address, source address, length indicator. At that time it will make the header to the frame it reads, and the last 2 bytes length indicator. It will determine the amount of data which we are supposed to send. By that it will know it has to expect the end of frame. So after that we can send the data number of bytes plus 4 cycling redundancy check. So we can send here data. So apart from that we will use here time gap to separate the frames, which will be waiting in between the frames. So here we have seen about the frame synchronization. Remaining we will see in the next class. Thank you.